A bobcat just killed a 50-pound snake that should have killed it first, and the man who found the body could not stop staring at the trail camera footage. For 20 years, everyone who studied the Florida Everglades believed they already knew how this story would end. A giant snake moves in. The small animals disappear one by one. The swamp goes quiet forever. That was the accepted ending, and almost nobody thought it could change. But new footage from inside Big Cypress National Preserve is now forcing biologists to rewrite everything they thought they understood about this fight. It is not proof that the crisis is over. It is something stranger. It is the first real sign that the swamp itself might be starting to push back. Before any of this makes sense, you have to understand what the Everglades actually is, because most people will picture a random patch of muddy water full of alligators and mosquitoes. That is not even close to the truth. The Everglades is a slow, wide river of grass that once stretched across almost all of South Florida. It filters drinking water for millions of people. It soaks up storm surge during hurricanes. It refills underground aquifers. It cools and stabilizes the regional climate. Economists have put its value in the tens of billions of dollars every single year, not because it is scenic, but because of the quiet, unglamorous work it does every day just by existing. Inside that system lived one of the richest food webs in the entire country. Wading birds by the thousands, alligators patrolling the channels, raccoons, opossums, bobcats, marsh rabbits, gray foxes, deer, all stacked together in layers that had taken thousands of years to build. Picture what South Florida looked like before any of this started. Airboats gliding through open sawgrass prairies stretching to the horizon. Wood storks and roseate spoonbills lifting off in enormous flocks at dawn. Alligators sunning themselves along every channel bank, acting as the top predator the whole system had been built around for thousands of years. Underneath them, an entire chain of smaller animals kept the balance running, eating insects, spreading seeds, controlling rodent numbers, feeding the birds of prey circling overhead. It was not a wilderness people needed to protect out of sentiment. It was infrastructure, just built from water and grass instead of concrete and steel, and millions of people downstream depended on it working correctly whether they realized it or not. Then, in August of 1992, Hurricane Andrew slammed into South Florida as a Category 5 storm, with winds tearing past 165 miles an hour. Entire neighborhoods were flattened in minutes. Somewhere near Miami, a facility that bred and kept exotic reptiles was ripped open by the wind. When the storm finally passed, Burmese pythons were loose in the wetlands, and nobody was tracking how many or where they went. But the hurricane was never the full explanation, and it might not even be the biggest piece of it. Through the 1990s, Burmese pythons became a trendy, exotic pet across the United States. They were inexpensive, dramatic-looking, and easy to find at reptile expos. A baby python fits comfortably in one hand. It looks exotic and manageable. It does not stay that way. Within a few years, that same snake can stretch past 10 feet and weigh 50 pounds or more, and plenty of owners realized too late that they had no way to care for an animal that size. Some of them drove out toward the edge of the Everglades and released their snake into the wild, telling themselves they were doing something kind. What they were actually doing was introducing a living weapon into an ecosystem that had never evolved any defense against it. Then the survey data started coming in, and it was brutal. In the areas hit hardest, raccoon sightings had fallen by more than 99%. Opossum numbers were almost as devastated. Bobcat populations had dropped dramatically. In some of the worst zones, marsh rabbits and foxes were not simply reduced. They were gone completely, wiped from entire survey areas. Researchers who had worked in the Everglades their whole careers described driving down roads at night that used to be full of small animals crossing in the headlights and finding nothing. No movement, no rustling in the brush. The swamp still looked alive from a distance, but something had been quietly eaten out of the middle of it. Florida's first big public response was the Python Challenge, an open competition where hunters could sign up, head into the swamp, and compete for cash prizes based on how many snakes they caught. It generated headlines and got people talking, which mattered, but the actual math behind it was rough. The most recent Florida Python Challenge, held this year, offered up to $25,000 in total prizes and expanded because pythons have now been confirmed, spreading well beyond their original strongholds in the southern Everglades, reaching further north along waterways and warming corridors than officials expected. Even with growing turnout and bigger prizes, pulling a few hundred snakes out of a population that may run into the hundreds of thousands barely moves the needle. It is closer to bailing out a flooding boat with a coffee cup. Officials have also leaned on more than just human hunters over the years, testing several different pieces of technology along the way. Thermal drones were tested to spot pythons by their body heat, but the technique struggled badly because pythons are cold-blooded, and the swamp around them is often just as warm, so the snakes barely stand out from the background at all. Mechanical decoys were tried to lure pythons into range, but ambush predators do not chase a fake meal on command. They wait, which made the decoys mostly useless. One approach that has genuinely worked is the use of tagged male scout snakes released back into the wild during breeding season, since male pythons will instinctively travel toward females and lead researchers straight to nests that would otherwise be impossible to find. It is clever, effective science, but even the people running it will tell you it removes individual snakes faster than it shrinks the overall population. The state's paid professional hunting programs have had more staying power. Since removal efforts began, more than 27,000 pythons have been taken out of Florida's environment. A number that sounds massive until you learn that researchers believe only about 1% of pythons in the wild are ever actually seen or captured. That means the true population could be enormous compared to anything removal teams have documented. The most striking recent numbers came from a partnership between wildlife officials and a private company called Inversa, which helped triple the monthly removal rate within about 2 years, and from a single tracking season run by the Conservancy of Southwest Florida between November of last year and April of this year. In that stretch, biologists led by Ian Bartosek and his team used 40 tagged male scout pythons to locate breeding females across a 200 square mile stretch of Collier County. They pulled out 177 snakes weighing a combined 8,080 pounds, the biggest single season on record. The largest female captured weighed 153 pounds and stretched 17 feet long. Because researchers specifically target pregnant females, that one season alone likely prevented around 4,100 python eggs from ever hatching. That is genuinely significant work. But it also reveals how the pythons themselves are changing in response. Traps and hunting zones that used to produce steady results started going quiet in later seasons. Not because the snakes had vanished, but because they had shifted deeper into terrain that is almost impossible for a human to reach on foot. Field researchers have documented pythons moving farther away from areas with regular human activity across multiple seasons. That kind of pattern could mean individual snakes are learning to avoid danger. It could also mean something colder is happening underneath, natural selection quietly doing the work. The bold, careless snakes keep getting caught and removed. The cautious ones survive, breed, and pass that caution down. Either way, the outcome is the same unsettling trend. An apex predator that was already difficult to locate is getting even better at staying hidden. That has real consequences for anyone trying to plan a removal strategy years in advance, because it means the tools that worked well in one season cannot simply be scaled up and repeated forever. The population is not a fixed target, sitting still and waiting to be counted. It is actively responding to the pressure being applied against it, adjusting its own behavior in real time in ways that make each future season harder than the last, even as the technology and funding behind the effort keep improving. While all of that was happening above ground, a second threat was spreading almost invisibly underneath it. Scientists call it Railiatiella orientalis, more commonly known as the invasive snake lungworm. Researchers at the University of Florida were examining native species like garter snakes and pygmy rattlesnakes that appeared thin, weak, and struggling to breathe properly. When they opened these animals up, they found dozens of small parasitic worms packed into the lungs, blocking airways and feeding directly on tissue and blood. This parasite is originally from Southeast Asia. Burmese pythons can carry it without much trouble because their bodies evolved alongside it for thousands of years. Florida's native snakes have no such history and almost no resistance. The way it spreads is genuinely disturbing once you trace it. An infected python releases waste into the swamp. Cockroaches feed on that waste and pick up the parasite's larvae. Frogs eat the infected cockroaches. Native snakes eat the frogs. Once inside a native snake, the larvae do not stay in the stomach. They burrow straight through the stomach wall and migrate up into the lungs, where they attach themselves and start multiplying. As the infection worsens, the snake stops eating, its breathing becomes labored, and eventually it suffocates. In some of the most severe documented cases, worms have been found crawling out of a dying snake's mouth. What makes this parasite especially hard to fight is how ordinary every step of that chain looks from the outside. A cockroach in the mud, a frog hunting after dark, a snake eating what snakes have always eaten. There is no dramatic moment where the danger becomes visible, no single event you could point a camera at and say, that is where the damage happened. It just moves quietly up the food chain, link by link, using completely normal behavior as its delivery system, which is part of why it went undetected for as long as it did. The lungworm has now been confirmed in at least 18 different native snake species, and its range has already pushed well north of the original python territory, showing up in animals as far away as the Jacksonville area. Worse still, researchers have confirmed that the parasite no longer needs Burmese pythons to keep spreading. It is now passing directly between native snakes on its own, which means even a complete disappearance of every python in Florida would not make this parasite disappear with them. It has become permanent, self-sustaining, and largely out of anyone's control. So the Everglades has effectively been under attack from two directions at once. pythons hunting mammals from above, and a parasite quietly damaging the reptile populations that hold the middle layers of the food web together. But inside all of that bad news, researchers found one result that genuinely surprised them. The Florida cottonmouth, a venomous pit viper living in the exact same infected habitats as everything else, kept testing clean across repeated surveys. No worms, no breathing problems, no sign of infection at all. Nobody knows exactly why. It could be an immune response, blood chemistry, something related to its venom, or a mechanism nobody has identified yet. But if scientists can eventually figure out what makes the cottonmouth resistant, that discovery could become the key to protecting other native species from a parasite that otherwise has no obvious cure. Right now, that remains an open question rather than a solved one, and researchers treat it as one of the most urgent puzzles in the whole state's wildlife program, because every month spent without an answer is another month the parasite spends spreading further north in a territory that has never had to deal with it before. While researchers were still chasing that mystery, Florida did something that sounded backwards to a lot of people who first heard about it. State agencies and conservation groups started releasing more snakes into the wild. It sounds like the last thing anyone with a python problem should be doing. But the snake being released is not another invader. It is a native predator, finally returning to territory it lost decades ago. The eastern indigo snake, the longest native snake in North America. This is a glossy, blue-black animal that can grow past 8 feet, and unlike a python, it does not constrict its prey. It pins the animal with raw jaw strength and swallows it alive. It is also immune to the venom of North American pit vipers, meaning it can eat rattlesnakes, copperheads, and cottonmouths without any consequence to itself. The eastern indigo did not disappear because something defeated it in a fight. It disappeared because its habitat was destroyed. These snakes rely heavily on gopher tortoise burrows for shelter and temperature control, especially through cold snaps. As development wiped out longleaf pine forest across North Florida, gopher tortoise numbers collapsed, and the indigo snakes that depended on their burrows collapsed right along with them. By 1978, eastern indigos were essentially gone from North Florida, and the species was listed as federally threatened. Vehicle strikes along rural roads made the decline even worse, since adult indigos can travel several miles across open ground during warmer months, crossing highways that cut straight through what used to be unbroken habitat. For a long stretch of time, the species held on only in warmer pockets of central and southern Florida, while the northern part of its historic range sat essentially empty, a gap in the ecosystem that nothing else was built to fill. Researchers finally captured the moment they had been waiting roughly 50 years to see: wild-born eastern indigo hatchlings moving through the underbrush in North Florida. The first proof that this species was not just surviving after being reintroduced, it was actually rebuilding a population by itself. Field biologists who had spent years releasing and tracking these snakes, watching some thrive and others disappear without a trace, described that footage as the moment the entire project stopped feeling like an experiment and started feeling like proof. Every wild hatchling found afterward becomes another small data point confirming the same thing, that a species written off as functionally extinct in this region less than 50 years ago is now producing the next generation entirely on its own, without any human hand involved in the process. While that recovery was unfolding in the north, something unexpected was happening farther south, in the same swamps that had spent 2 decades losing this fight. Researchers, tracking a 50-pound Burmese python using a radio transmitter, followed the signal to what they expected would be a living snake. Instead, they found a carcass with its head bitten off. A nearby trail camera had captured the entire encounter. The animal responsible was a bobcat weighing roughly half as much as the python it had just killed. It had stalked the snake, found a vulnerable angle, attacked, and won. According to people familiar with the footage, the biologist watching it went completely silent, then immediately asked for every camera in the area to be checked, because reports of native predators turning the tables on pythons had started showing up in multiple locations across South Florida. Alligators ambushing smaller pythons. A Florida panther caught on camera taking down a mid-sized python out in the sawgrass. Predators appear to be learning exactly when a python is vulnerable, right after it has eaten a large meal, or during the brief window when it is crossing open water. Each of these encounters on its own could be dismissed as a fluke, a single unlucky snake in the wrong place at the wrong moment. But when field teams started comparing notes across different counties and different research groups, the pattern held up too consistently to ignore. Native predators that had spent 2 decades as prey, or at best as passive bystanders, were starting to actively target an animal that had dominated every previous encounter between the two. None of this means the pythons are losing overall. Numerically, they are still winning by an enormous margin, and one bobcat cannot undo 20 years of ecological damage on its own. But the direction of the fight has shifted from a one-sided slaughter into something that at least resembles a real contest, and that shift sets up a collision nobody has documented yet. Eastern indigo populations are slowly expanding outward from restored habitat in North Florida. At the same time, Burmese pythons keep pushing further north, following waterways and warmer temperatures into new territory. Their ranges are moving toward each other, and at some point, probably not too far in the future, they are going to meet. Picture it. A fast, aggressive, venom-immune snake evolved specifically to hunt other snakes, coming face to face with a Burmese python that could easily outweigh it by 40 pounds or more. The indigo's advantage has never been size, it is speed, raw jaw strength, and a refusal to let go once it is locked on. It has taken down rattlesnakes and cottonmouths without hesitation. But it has never had to face anything built quite like a fully grown Burmese python. Nobody has ever recorded that fight because it has never happened before. Some biologists expect the python to win most of these encounters simply on raw size and strength. Others point out that the indigo did not survive millions of years as a snake-eating specialist by picking fights. It could not win, and that its whole hunting style is built around exploiting exactly the kind of weak points a heavy, slower-moving python cannot easily protect. Nobody actually knows which prediction is closer to the truth, and that gap between theory and reality is precisely what researchers are now racing to observe before it happens somewhere out of view of any camera. And there is a darker possibility layered right underneath that one. The lungworm parasite is also moving north, following roughly the same corridors as the pythons. If eastern indigo populations expand into infected territory before anyone understands whether they have any natural resistance to it, decades of careful restoration work could walk straight into a biological trap that nobody saw coming. Nearly 10 years of reintroduction effort could collide with a parasite that currently has no known cure and no way to be stopped once it takes hold in a new species. It would be a strange, quiet kind of tragedy, a comeback story nearly 50 years in the making, undone not by the invader everyone has been watching, but by something microscopic riding along the exact same corridors the recovery program worked so hard to open up. That is the real story hiding underneath this footage. It is not a clean victory, and it is definitely not a total collapse either. It is something messier and far more interesting, a damaged ecosystem searching for a new kind of balance between an invasive giant, a spreading parasite, a native predator clawing its way back from the edge of disappearance, and local animals that finally seem to be learning how to fight back on their own terms. None of the individual pieces of this story would sound remarkable on their own. Say, one dead python, one released clutch of hatchlings, one snake species that happens not to catch a particular parasite. But laid out side by side, across the same swamp, in the same handful of years, they start to look like something closer to momentum. A system that spent 2 decades absorbing damage in total silence, now generating small, scattered signs of resistance in multiple directions at once. The bobcats are adapting. The eastern indigo is reproducing in the wild again. The cottonmouth might be sitting on a biological clue nobody has cracked yet. And after roughly 2 decades of near total silence, the swamp itself is no longer just standing still and absorbing the damage. Nobody can honestly tell you how this ends. Does the eastern indigo expand fast enough to actually matter before the pythons get there first? Can it hold its own against something so much bigger than any prey it has ever hunted before? Does the lungworm reach it first and undercut the entire recovery effort before it even has a chance? Does the cottonmouth's mysterious resistance eventually turn into an answer that protects other native snakes? Do bobcats, panthers, and alligators keep adapting fast enough to actually shift the numbers over time? Nobody studying this has a confident answer to any of those questions right now. And that uncertainty is exactly what makes this moment different from the last 20 years of the story, when the trajectory only ever pointed in one direction and everybody already knew roughly how the next survey report was going to read before it was even published. For the first time since this invasion began, the ending genuinely is not written yet. Tell me who you think wins this fight down in the comments: the python, the parasite, the returning indigo, or the native animals finally learning to strike back. And subscribe, because the swamp is not finished writing this story, and neither are we. And the next season of tracking data alone could completely flip which side of this fight looks like it is winning.